place in the manhole is look on the center line. The center line is right in between these inverts, because we, in essence, doesn't even matter if this thing, let's say it's on this side. We still go from here to the center and then back through the other invert. So where do you think the center of this manhole is going to be placed in relationship to the inverts?
In the middle.
In the middle. So when you are defining the manhole, what you want to do is locate a single line. I know you just kind of go and look at, I don't know, well, I'll look at manhole 2 here. Manhole 4, actually. So here, I've got the station mark right here. That's a vertical line. You can all locate the station mark, right? Then I'm going to come down here and I see, you know what, I'm 06.16, 06.6. I need the manhole. Because I'm going to place the manhole, the inverts are already made, and then I'll rotate it to line up with my pipe. So I'm just going to take these two values right here and average them. So the elevation of this is 0.11. So it's 3706.11. Any questions where I got that number? Okay. So what you'll want to do is you'll want to go through and draw a line for each one of these manholes that has the top, which is given to you, station, elevation. The bottom's given to you, elevation, it's on the same station. Locate that line. Then to draw the bottom of the pipe, all you do is use a P line and snap right through these inverts. We go back to the drawing.
I still don't understand what an invert is.
It's that pipe, it's that hole for the pipe.
Oh, so it's just the hole where the pipe fits?
Yeah, that's it. Okay, so that's how I drew this line right here that I just selected. Because what you're going to do is you're going to come through and you're going to have a line, like manhole number 4, we've got a line that goes from there to there. Right? And I do that for every manhole. Then I just take a P line and I snap, point, 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 point. Done. Don't make it harder than it is. So that's how you get the bottom of the pipe. That's the important dimension. Remember, it is a gravity system. How did I get the top of the pipe?
Offset?
Yep, I did do an offset. What was my offset distance?
Isn't it 8-inch pipe?
It is. Okay. So it's an 8-inch pipe. Don't offset it 8 inches. You got to convert that, right? Because this is a vertical scale. You're showing the limiting elements of that pipe, bottom and top. It's 8 inches is 0.67 feet. So to get 0.67, I got 0.5 plus 0.1 plus 2 times that's 0.6. Do this right here. So I'm taking 0.67 and breaking it down. So that's a 0.5 plus 0.1 plus 0.05 plus 2 times 0.01. Then you just substitute in the values, right? 0.5 is 10, plus 0.1 is 2, 0.05 is 1, that's 2 times 0.2 plus 0.4. My offset distance is 13.4. Declan, you mentioned you were doing this a different way. How would you do this?
20 times 0.67.
Yeah, because the factor here between 1 to 100, 1 to 5 is 20, right? So he's taking 0.67 times it by 20, what do you get? Somebody crunch those numbers. Do we get the exact same number? It's a proportion deal. I just broke it into numbers for you. But certainly you can do that also, whichever way you feel is easiest. Yes, Sean?
So where do you get the 0.67 from? To break
8
it down?
inches divided by 12,
Okay,
because we're decimal feet.
okay.
Okay, so I'm going to offset that distance, and that's the top of my pipe. Now, how am I going to draw these manhole systems? And by the way, check your Schedule 2, because we have a different symbol for an existing versus a proposed manhole. And we also have a different symbol for a manhole from a plan view to a cross-section view. So you're going to show manholes actually 3 different ways on this drawing. Now, how did I get this symbol? Because it's a symbol, but it's a very prominent symbol, right? It's the whole purpose of doing the map. I'm not going to draw that concrete thing here. Somebody else is going to draw that detail and send it to Triple C. What we're going to do is do a symbol, and I would like you to make the symbol 1/4 inch, and since it's prominent, it should have a very dark line weight, or a heavy line weight. So in essence, if I'm going to make this a 1/4 inch, right here, what's my DSF? I'm going the horizontal direction. 100, isn't it? What's a 1/4 times 100? We're going to make it 25 wide. So I'm going to take this center line right here that I drew. Got a nice straight line, Pat. And I'm going to offset that 12.5 both ways, and then just trim it up and draw a triangle. One last thing to kind of point out on this that you might want to be confused on is, I need to change this so you can see it. It is a pipe, so please put the proper pipe break. Now, I don't have the proper pipe break on here, and you're not going to get the proper pipe break at this scale because it's a pipe, right? So a pipe one actually looks something like that, and we hatch it, chapter 16. You'll never see that at this scale, so just do like a solid pipe break, and do not hatch it. The ellipse works great on that. Other than that, it's just a little bit of labeling and you're done. Okay, so we got contours. Where's my red pen? 2, we've got our pipe. 3, we've got our manholes. Existing and proposed. Once we do that, we are then into the annotation portion of this drawing. We don't need to do any dimensioning on this at all because it's all located with your grid. Every bit of it's located with the grid. Located and sized, actually. Now, what's this? Let me just ask you a quick question. What is this kind of display about this? What are some assumptions you can make on this sewer line?
Running down.
Yeah, running downhill.
And you have to grade to get, you're gonna have to grade.
Yeah, what's got with the
It's
surface?
underground, it's underground.
Surface is going to be changed on this, isn't it? It's not going to do me any good to have a manhole like this one sticking up in the air. I'm going to have a lot of ticked off public when they start ruining their vehicles running into my manhole. It doesn't do us any good if it's sitting down here either. This is going to be the final surface of the road. Now, we're not doing the plan profile of the road, but it will match the top of those manholes. That's where that came from. Look at the sewer line slope, 0.4. Is that 0.4 rise over run, or what is that? 0.4%, right? So what does that mean? That means for every 100 feet, this thing's going to drop how much? What's that?
0.04.
0.0.
Oh, 0.00.
0.004. Very slight slope. Typically, these will run somewhere between a 1/16 of an inch down to 1/28 of an inch. This is equivalent to what? Well, 1/32, so 3. So we're about 1/64 on this one. Now, the reason they do that, there's two reasons that you may not be aware of. So when I drop sewer into this, I've got fluids, but I've also got solids. And so you can't slope it too much or your fluids outrun the solids and then you get some blocks. Okay? So it's got to go at a very slow rate so that everything stays suspended. Additionally, due to the physics of it, and this is kind of an interesting deal, is that you'll get a vortex system based on drop. So if this, we've got kind of street water coming down right through here, right? You know, something like that. Think of that. A drain or whatever is all going into this. If it hits here, as I look at that pipe, that fluid's going to come in and hit here. And if I've got enough velocity and it's slow enough thing, it actually does this as it goes down the pipe. So it sits there and spirals as it goes down the pipe. So it also is self-cleaning. And if you don't get that slope just right, then it doesn't do that, then hence you get buildup on it also. So the slope is really, really picky on these to provide long-term maintenance where we don't have to jump in there and clean these things all the time. And nobody really wants to do that. There is some jobs Americans won't do. One of them. Although, pay me enough, I got to do it. Where'd you get that slope, by the way, and the length of these pipes? Right in your paper. Okay, so all you're doing is later. All right, so last thing we've got to do is annotate. Now, I went and put up this drawing over here so that you can use it as a guide to help you annotate. All right, last thing to print. You need to print. So we are printing this out of model space. We're not going to paper space. So does anybody remember the variable I have to set? Yes. Line type scale. So when you type in LTS, okay, it's already set right now on 100, or at least mine is. I don't know what yours is. But line type scale, we set it at 1 when we print out a paper space because our viewport then applies this value. So we're not using a viewport here. You must set this variable to 100, and then you print everything else exactly the same, except in your print window. Okay, there is one change. Okay, so if I'm getting ready to print this, oh, by the way, let me just point this out. See these two boxes out here to the left? Mm-hmm. You won't print those. Okay, they don't fit in your 36 by 24. Okay, so just ignore those two boxes. Those are for EHM's internal use. Okay. So if I go into print, the only other thing I have to do is over here on your scale, we normally need this 1:1, right? Because our viewport also does our scale. You're going to need to put this at 1 to 100. That's the only other change you'll do. So line type scale, set to your DSF. Set scale in the print window. And then you're still going through our plotter, D sheet, blah, blah, blah. Okay?
What, you have it done at 1 to 824?
Yep, that's what mine says. What will yours say, Cheryl?
1 to 1.
No? It
1
won't.
to 100.
Yes, it will. I hope it will. If you want it to match up with my key, it will say 1 to 100. Okay. Any other questions of stuff we didn't cover here? Let's just go ahead and add this real quick. We got one last thing here. We're print. Print. In model space. 1. LTS is equal to your DSF. 2. Plot scale to PSF. Okay? Yes.
So it says in here that you want us to use the freehand style in lowercase, is that standard? And these kind of civil drawings, is you using the lowercase?
Civil does kind of go back and forth a little bit, where sometimes they'll use lowercase letters.
So you want us to-
They're about the only industry that does.
You want us to follow that?
Yes, please follow the instructions in the text. Yes, Sean?
And so the points that we use to like map everything out on the profile view, we don't print those, right? We can delete those after we've got our points there?
I wouldn't delete them. Create another layer, call it profile points.
Okay,
Stick them on there, freeze it, or set it not to plot.
okay.
Cheryl?
Why are we printing one model space instead of one way?
Because it's about time you guys saw it.
Oh, so it's just a learning.
Yeah, there's firms in our town that don't use paper space. A couple of them. In fact, I discussed this, and this brings me into another topic, and then we'll take a break. I've discussed this extensively with my advisory committee, and they are adamant that you are able to plot in both a paper space and model space environment. Because all drawings pre-version AutoCAD 2000i were all done in model space. So if you're archived old drawings, that's the way you're gonna print them. They don't want you to take the time to reconfigure the whole thing to print out a paper space. So they want you to know both.
And that's your rule for, I mean, this print section?
Oh yeah, that's how you do it. You'll get the exact same result.
Okay, so that's
This is the same way to plot almost anything. The place this falls down is when you run multiple scales on the same sheet. Now, I'm not taking you that far to figure that out. You might not remember, but back in 132, when I talked about viewports and started giving you examples like architectural, where I've got different scales on the same sheet, details, plan views, these types of things, you had to be a proportion genius. It would take me 4 or 5 days to teach you how to do that. And I'm glad I don't have to do it anymore. And I'm sure you are also.
Yes, we are.
Because after 3 or 4 days of it, I know some of you still wouldn't have it. There's ratios you're running left and right, and you better take good notes, because if you open that drawing up 15 years from now, guess what you gotta do? Figure all that crap out again. But yes, they want you to know how to do it. Now, with that said, advisory committee. This is a group of people who are going to be eventually many of your employers. In fact, one of yours, Dan Karst, is actually on it. One of your employers. It's made up of a group of people from around pretty much the southern half of the state that are going to come in here, and they advise me on curriculum. We're going to have that meeting on Thursday. So therefore, on Thursday, I would like you to close up shop about 11:45, and you're off for the day. Now, that is also trig. So the trig people are back here at 2:30 for their mock final, practice final. We should be done by 1:30, but it might run a little bit long if you want to come back. Missy, your club president, has been invited to this, so she's coming to it. She'll probably be asked for her insight as a student doing it, so you're going to be an active participant, whether you know it or not. And also, she'll bring that information back to you. That's why I always invite the president of the club. Missy, that's why you got it, is that you could, there's nothing secret in this thing. Okay, so please bring that information back and let the class know what we discussed, because it doesn't affect you that much this year, but you can kind of get how this was put together. Please clean your areas. Okay. These folks, in essence, I consider them my client. Okay. Now, we talk about that all the time, where I've got clients in this, right? Consultants, these types of things. Well, in essence, these people are our clients, because what's our product coming out of this lab?
Us.
It's you guys, right?
Yeah.
They're the ones buying. And I don't mean to put it in that term, like, oh, I'm a slave. No, that's not the way it works. But they are, in essence, hiring you. This is a good source for all the curriculum you have. In fact, much of this curriculum came from people on this advisory committee. This drawing came from a member of this advisory committee. So they help with curriculum. They help guide us on what we want to do. We're going to discuss a few items about the spring semester with this group this year. And I've got some new members. I've got the INL on it, CTAs on it. They're both making an appearance this year. We also got another local firm here that's going to be on it, so it's growing a little bit also. With that said, please have your areas spotless, okay? Because we want to put a good impression of our room up here. I'll probably go through the room tonight and kind of tidy everything up on the peripheries. You take care of your area, please. Okay, we'll be eating at the desks and everything like that, so don't leave anything on them. Everything needs to be off and gone by Thursday. when
Computer
you-
shut down.
Yeah, we can shut the computers down. We won't be using them. That will be Thursday, this Thursday. Now, one other thing to put on your schedule, and then we'll take the break, is Monday, we're going to do the stakeout on the softball field. So I'll explain much more of that tomorrow. So we're going to that tomorrow. We're going to take a break, and I've got one other topic I want to get into, and I'm going to try and be fairly quick with it. So,
Can I ask one more question?
yes.
please?
Mhm.
You changed on your line weights to dots over there?
What?
Yeah, turn on the bottom or profile. You doing that?
Yeah.
Oh, yeah, line weights. I just kind of made some recommendations on it.
Yeah. You want to follow that?
Sure. You'll get a result.
Okay.